lunch also. Okay, so I was telling you about the errors in the pH measurement, and one of the error is because the potential of the reference electrode is 0, not at pH 7, but it is potential 0 at a different pH. Or in other words, at a pH of 7, ideally we expect that the potential should be 0, 0, but it is deviating from that value of 0. Okay, so when such is the case, should we throw away the pH meter? Is it of no use to us? No, it's not like that. What we do is the pH meter, on the pH meter setting, actually there is a knob by which we can make some adjustment. Okay, so plus or minus maybe 2 units we can make the adjustment, and therefore when we are actually making that adjustment, it is actually meaning that at the pH of 7, the pH meter will actually show you a potential of 0, 0. Okay, so that kind of adjustment can be made, right? So we are adjusting the error so that every time we measure the millivolt or the pH of a particular solution, the reading is going to be correct. Okay, there will be no error in the reading. Have you understood what I'm saying? Okay. Then the other kind of error is like this, that normally what happens is whenever there is a change in one pH unit, okay, if I have a solution of say pH 7, and then I put a solution of pH 8, okay, then for that every 1 pH unit change in the solution, okay, the potential changes from a value, changes with a value of 59.16 millivolt. Okay, 59.16 millivolt is the change in the potential for every pH unit. Are you getting what I'm saying? Shall I repeat it once again? Okay, we have seen one type of error in which the electrode will show you a potential of 0, 0 when the pH is 7. But at the pH of 7, that is in distilled water, if the potential is not 0, then it means that there is an error in the reference electrode, and that error can be corrected by adjusting a knob which is given for the 0 shift. Okay, there is a knob for 0 shift by which we can make that particular adjustment, and then we can tell the instrument that whenever we put distilled water as a sample, then the pH meter should give the millivolt reading of 0, 0. Right, that was correcting error number 1. And now the other kind of error is like this, that if we have a solution of a particular pH, say pH 6 or pH 7, and then we put another solution of pH 8, that is a 1 unit change in the pH, then for every 1 unit change in the pH, the millivolt value will change by 59.16 millivolt per pH unit. Okay, now if that value is a little different because of some error in the pH meter, usually due to worn out electrode, if you are using a particular electrode for a very long time, okay, then this particular error will come up, and that error is like this, that for every 1 unit change in the pH, the value of change in the millivolt or in the potential is not 59.16, but it is a different value. Okay, so even that adjustment can be made, that error can be corrected by using a knob which is given on the pH meter. But of course, it will have a certain limitation, a certain range. Okay, for example, 95 to 105% error in the in your reading can be corrected. But if your pH electrode is too old or it is too worn out electrode, then the adjustment cannot be made, and then you have to replace the electrode with a new electrode. Have you understood what I'm saying?
Yes.
Yes,
Okay.
sir.
Okay, then coming to calibration of a pH meter, every time we are going to use a pH meter in the laboratory, every day rather, okay, every day early thing you do in the early morning is that you have to calibrate the pH meter. Okay, once the pH meter is calibrated, then you can use that pH meter throughout the day. Okay, So normally what we do is we have three kinds of buffers. One is a buffer of pH 4, one is a buffer of pH 7, and the third buffer is a buffer of pH 9.2. Okay, usually these are all phosphate buffers, because phosphate buffers can be made with this particular range of pH values. Okay, pH 4, pH 7, and pH 9.2. Right? And then what we do is when we calibrate the pH meter, we are actually telling the pH meter that, look here, whatever solution I am using here in which the pH electrode is dipped, okay, we are assigning a value to that pH meter. For example, if I dip the pH meter electrode in a buffer of pH 4, the instrument doesn't know that this is pH 4, isn't it? We have to tell the instrument that call this as pH 4. Okay, so we set the value to pH 4, then we remove the electrode, wash it carefully, and then put it in another buffer. And this time the buffer is, say, pH 9.2. The instrument doesn't know that this is pH 9.2. So again, you have to tell the instrument that, look here, this is a buffer of pH 9.2. So the instrument will automatically calibrate itself, and then it will call that particular solution as a solution of pH 9.2. Okay. And then when you put that electrode in a buffer of pH 7, then normally, automatically the instrument should know that this is pH 7. Okay. But if the value is not exactly 7, if it is a little different value, then you can again calibrate the instrument for the third time, in the third step rather, and then you tell the instrument that call this particular solution as a solution of pH 7. Okay. So having done that, what you have done, you have actually trained the instrument. Okay, you are actually training the instrument to call a particular buffer with a particular value, or assign a particular value to that particular buffer. Okay, or rather assign the value to the pH meter itself. The pH meter is trained to call that particular solution as a solution of pH 4 or pH 9.2 or pH 7. Okay, and once your calibration is over, then you are going to put the electrode into use. You are going to put the electrode in a particular sample solution of which you do not know what is the pH. And then when you put the electrode in that particular sample, the pH meter will give you the particular value of the pH. Okay, so that value will be assumed to be a correct value because you have already calibrated the pH meter. Is it right?
Yes, sir.
Okay. And then we go probably to the last slide of this presentation. And that is how to take care of the glass electrode. The glass electrode, as you know, are having a very, very thin membrane at the distal portion, the portion which is going to be actually put into the sample solution. Okay. And if your actions are jerky, if by mistake your electrode touches the sides of your container, liquid container, and if that it is not just touching the side, but if there is a kind of impact, okay, then that impact will result in breakage of the glass membrane. There will be either a small crack or the complete glass membrane will break up, and that will actually spoil your electrode, and you have to, there is no other option but to replace your glass electrode. Okay, do you know what is the cost of a glass electrode? Any guess? What is the price of a glass electrode? No. Okay.
No, sir. No.
Okay, the price is something ranging from about, say, 3,000, I'll say. Okay, 3,000 plus or minus something, of course. Okay, it may be 2,500 to maybe about 5,000 rupees. Okay, that is the price of a glass electrode, and you will know the price only when you break up one electrode, isn't it? So when you come to the department, you break one electrode. Okay, and then when we'll ask you to replace the electrode with your own money, then you will know the exact price of the electrode. Is it okay? So how many of you want to break an electrode and pay for the price?
No, sir.
No, you don't want to know the price of the electrode?
No, sir.
No. There is another way to know the price, and that is you go to the catalogs. Okay, catalogs are available, or even on the internet you can search. Okay, you can get the price quote for a glass electrode for pH measurement, and then you will know the price. Okay, so taking care is sometimes what happens is after repeated use of the electrode, the sensitivity of the glass membrane becomes less. And then it is very much essential to wash that particular electrode with what is called as a hypochlorite solution. Okay, or sometimes you can even wash it with the normal way we do it is we immerse the electrode in 1 molar NaOH solution, okay, for some time, maybe a few hours or maybe overnight. And then again, we remove the electrode and put it in HCl solution of 1 molar concentration, again for overnight. And then that should normally clean up the electrode and then it becomes sensitive once again. But with that procedure, if it doesn't become sensitive enough, then maybe you can use an etching solution, which consists of 20% ammonium bifluoride. Okay, and then that is followed by immersing the electrode in a 6 molar HCl solution. Okay, but even with that, if the electrode doesn't regain its sensitivity, then the best way is to replace the electrode with a new electrode. Is it okay? And
Yes.
then one thing I have told you is this electrode should always be kept in distilled water because the hydration of the glass membrane should be proper. If the membrane goes dry, then the pH meter electrode is of no use. Okay, so with that, my lecture is over. And if you want time for lunch and then attend the next lecture, then we would immediately close the meeting. Or if you want to discuss something, or if you have questions, then you can quickly ask me your questions.
So the problem solve किया था ना yesterday?
Yes.
The problem number 3 है, तो उसमें एंटी लॉग यूज किया, बाकी इसमें नहीं किया था.
हाँ, correct.
तो
Actually,
बाकी
हमको
इसमें
वो
एंटी लॉग
proportion चाहिए ना. We want that proportion value. That is not a logarithmic value. We want the value in normal terms, isn't it? I'll go to that question. Okay, I'll expand the view.
क्वेश्चन नंबर 3 यूज एंटी लॉग.
थर्ड में देखो ये इधर है ना, log of acetate to acetic acid is equal to pH minus pK. Okay, so when we calculate that, pH was 5.30 minus 4.76, and then you get this particular value 0.54. This value actually is the log of acetate upon acetic acid. Okay, so in order to get the actual value for acetate to acetic acid, this log term, this should go away, isn't it? इसको निकालना पड़ेगा ना log को.
हाँ.
So how do we do it? We take the anti-log.
Okay.
Okay, anti-log of log.
Yes.
Anti-log of log is that number itself. है ना?
Yes sir.
तो जैसे माइनस करो और प्लस करो with the same number. Okay.
Yes sir.
The number will be same.
Okay. Okay.
है ना? 5 minus 3 plus 3 कितना हुआ? 5 minus 3 plus 3.
Same.
मतलब 5 ही हो गया ना?
Of 5.
Minus 3 की और plus 3
Five.
क्या मतलब वही रह गया number. So
Five.
similarly, when you take the anti-log of the log, it is that number itself. Okay, तो इधर log value है, ये log का हमको log नहीं चाहिए हमको. We want the normal value, so you take the anti-log of that value. Right? Any other question? Okay, if there are no questions, then I will end the meeting. And if there are any questions which will come across any time later, you can just note down your question, and either in the next lecture you can ask me the question, or you can also ask me personally on the personal chat or on the group chat. I think it will be better on the group chat also, so that everybody will come to know about the problem and the solution. Okay.
Yes sir.
So goodbye,
Yes.
everybody.
Yes.
Bye.